Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, so this video is to discuss point 6.3 about inverse function. So the learning outcome at the end of the lecture, students should be able to find inverse of a matrix by using adjoint matrix and by using elementary row operation. Okay, so as stated here, there are two methods to find the inverse of a matrix. Okay, the adjoint and the elementary row operation, or also be known as ERO, arrow. Okay. Okay, so now let's first focus on the first method, which is the adjoint matrix. Okay, so by the formula of inverse function, to find the inverse of A or matrix A, which indicates as A inverse, is equal to 1 over determinant of A multiplied with ADJA. Okay, what is meant by ADJA is actually the adjoint of matrix A. Okay, for the determinant, you already know how to find the determinant. Okay, so for now, let's focus on how to find the adjoint of matrix A before can we proceed to find the inverse of matrix A. Okay, for adjoint of a matrix, okay, let's say we have a matrix A where the elements are A11, A12, A13, A21, A22, A23, A32, and finally A33. Okay, so this is a normal matrix where the element inside is known as A11, A12, A13. Okay, so in order to find the adjoint, what we need to do is we need to change all of the elements inside matrix A with its cofactor. Okay, because the adjoint of A is equal to, okay, in the original equation, original matrix, we have A11, but in adjoint we have C11, where we find the value for cofactor for the position row 1, column 1. So on for all of the others elements. C11, C12, C13, C21, C22, okay, C31, C32, and C33. Okay, so this is how you find the adjoint. And one last thing is to transpose the matrix. Okay, first you do find the cofactor for each position of the elements inside matrix A, and then you transpose the cofactors in the matrix, and then you have found your adjoint. Okay, now let's look at an example. Okay, let's say we have a matrix B, okay, where the elements are 2, 3, -1, -1, 0, 5, 4, 1, -2. Okay, so we want to find the adjoint. Find adjoint matrix B. Okay, so in order to find this, what we have to do is we have to find the C11, C12, C13. Okay, so that means we have a total of 9 cofactors that need to be found. Okay, so now let's do for C11. Okay, in order to find the cofactor, okay, if you do not remember, I prefer you to do some revisions back on the previous video, okay, where the method to find the cofactor is actually related to the minor. Okay, so for this cofactor, which means we have a -1, 1 plus 1, and the minor of M11. So that will be -1, 1 plus 1, 0, 5, 1, -2. Okay, so that is the formula to find the cofactor at position 1, 1. Okay, so now we have -1 to the power of 2. Okay, so this is 0 multiplied with -2, minus 1 multiplied with 5. Okay, so we have our cofactor for C11 is negative 5. Okay, so that is what you need to do for the rest of the other cofactor. Okay, C11. Now let's do for C12. Okay, C12 is negative 1, 1 plus 2. Okay, then the minor for C12 is negative 1, 5, 4, and negative 2. So we have negative 1 to the power of 3, and negative 1, negative 2, minus 5, and 4. Okay, so here we have our cofactor is equal to 18. Okay, then C13. So C13 is negative 1, 1 plus 3, negative 1, 0, 4, 1. So negative 1 to the power of 4. Okay, we have a negative 1 multiplied by 1 minus 0 multiplied by 4. Okay, so that will be a negative 1 for our cofactor at position 1, 3. Okay, so now let's do for the rest of the cofactor in the matrix B. So C21. Okay, so C21, negative 1 to the power of 3. Okay. So 3, negative 1, 1, and negative 2. Okay, so now for this one, we have equal to 5. C22 is equal to negative 1, 2 plus 2, 2, negative 1, 4, negative 2, and the cofactor is 0. C23, negative 1, 2 plus 3. Okay, row number 2, column number 3 is 2, 3, 4, 1. Okay, then this one is equal to 10. Okay, C31, negative 1, 3 plus 1, 3, negative 1, 1, negative 2. So equal to 15 as the cofactor. C32, negative 1, 3 plus 2 multiply with its minor. So C32 is 2, negative 1, negative 1, 5. So this is equal to negative 9. Oh, sorry. I think I have made a mistake here for C31. So C31, column row number 3, column number 1 is actually 3, negative 1, 0, and 5. 0 and 5. Okay, then for C33, negative 1, 3 plus 3, we have 2, 3, negative 1, and 0. So this is equal to 3. Okay, so now we have all of the cofactor in each position in the matrix B, and then we write down the adjoint for matrix B is equal to the cofactor C11, negative 5, 18, negative 1, 5, 0, 10, 15, negative 9, and 3. Okay, but don't forget to transpose this matrix. Okay, when you transpose, you change the row and the column. So then it will be negative 5, 18, negative 1, 5, 0, 10, 15, negative 9, and 3. Okay, so this will be the final answer for adjoint B. Okay, now let's do on another example. Okay, now we have a matrix A equal to 5, 3, negative 1, 2, 1, 0, 4, negative 2, 1. Okay, now we want to find the adjoint for matrix A. Find A, DJ, A. Okay, so just as before, we have to do the cofactor, find the cofactor for each of the elements in the matrix A. Okay, for C11 equal to negative 1 to the power of 1 plus 1. Okay, so for now we have 1, 0, negative 2, 1. So this is equal to 1. C12 negative 1 to the power of 1 plus 2. Okay, so C12 first row, second column, so means 2, 0, 4, and 1. So this is equal to negative 2. So C13 negative 1 to the power 1 plus 3, 2, 1, 4, negative 2. So equal to negative 8. So C14, oh sorry, there's no C14. So it should be C21, the second row and the first column. So negative 1, 2 plus 1, 3, negative 1, negative 2, 1. Okay, so for C21 will be equal to negative 1. C22, negative 1, 2 plus 2, 5, negative 1, 4, 1. So C22, the cofactor is equal to 9. Okay, so then C23. Okay, C23, negative 1, 2 plus 3. Okay, for this one, the second row and third column means we have 3, 5, 3, 4, negative 2. Okay, then the answer for cofactor is 22. Okay, then C31. So, negative 1 to the power of 3 plus 1. Third row, first column, so we have 3, negative 1, 1, and 0. So that will be equal to 1. Okay, that is for C31. Then C32, negative 1. Okay, C32, so third row, second column. So will be 5, negative 1, 2, and 0. So equal to negative 2. And finally, the cofactor C33 is negative 1, 3 plus 3. Okay, third column, third row, third column. So we have 5, 3, 2, 1. Okay, so that will be equal to negative 1. Okay, so we have passed the difficult part. So now just left the easy part, which is just to fill up the value of cofactor into the adjoint of A. So 1, negative 2, negative 8, negative 1, 9, 22, 1, negative 2, negative 1. And don't forget the final step is to transpose this matrix. 1, negative 2, negative 8, negative 1, 9, 22, 1, negative 2, negative 1. Okay, so this is the answer for adjoint A. Okay, so now we want to look at one more example. Okay, how to find an adjoint if the matrix given is a 2 by 2 matrix. Okay, so in order to find the adjoint for matrix A, we have to follow the same step. find the cofactor for each of the position in the matrix. Okay, so we have to find the C11. Okay, so the C11 in cofactor for a 2 by 2 matrix, which means we remove the first row. Okay, we remove the first row and we remove the first column. So then we only have 4. So we just follow the negative 1, 1 plus 1, and we have right here another 4. So here will be equal to 4. So that is the cofactor C11 for the matrix A. Okay, then for C12, so negative 1, 1 plus 2. Okay, the first row, second column, so right here we have 3, so equal to negative 3. C13 equal to negative 1, 1 plus 3. Okay, the first row, sorry, this is not C13, this should be C21. Okay, 2 plus 1. Okay, okay, C21. So we have the second row, first column, we have here in negative 2. So it will become equal to 2. So then C22 equal to negative 1. 2 plus 2, we have 1. And right here we have the final answer equal to 1. So this is the cofactors for 2 by 2 matrix. Then in order to find the adjoint, we substitute it back into the matrix. So 4, negative 3, 2, 1, and then don't forget to transpose the matrix, then it becomes 4, negative 3, 2, and 1. So that is the adjoint for a 2 by 2 matrix. Okay, so now we have finished discuss about adjoint. So now let's find the inverse. Okay, let's say we have matrix B equal to 1, 2, 3, negative 1, 1, 4, 2, 0, and 1. Okay, now we want to find B inverse. Okay, so this is the inverse of B. Okay, based on the formula of inverse, so B inverse should be equal to 1 over the determinant of B multiplied with adjoint of matrix B. Okay, so which means firstly we have to find the adjoint. Okay, now let's do the adjoint first. Okay, the adjoint of B, okay, the C11, we have to find the cofactor for each position in the matrix. Okay, C11 will be equal to negative 1, 1 plus 1. Okay, we have 1, 4, 0, 1. Okay, this is equal to 1. C12, negative 1, 1 plus 2. Negative 1, 4, 2, 1. And equal to 9. C13 equal to negative 1, 1 plus 3. Okay, the first row and third column, which means negative 1, 1, 2, 0. And this is equal to negative 2. Okay, now we have finished the first row. Now let's do for the second row, C21. So negative 1, 2 plus 1. So the second row, first column, so we have 2, 3, 0, 1. So this is also equal to negative 2. C22, 2 plus 2, okay, 1, 3, 2, 1. So equal to negative 5. C23 equal to negative 1, 2 plus 3, and 1, 2, 2, 0. So equal to 4. Okay, so that is the cofactor for the first and the second row. Then cofactor for the third row, C31, 3 plus 1, 2, 3, 1, 4. Okay, this is equal to negative sorry, this one is equal to 5. Then C32, negative 1, 3 plus 2, 1, 3, negative 1, 4. So this is equal to negative 7. And finally C33, negative 1, 3 plus 3, and 1, 2, negative 1, 1, equal to 3. Okay, so now we have all the cofactors. We substitute it back into the matrix form. So adjoint of B equal to 1, 9, negative 2, negative 2, negative 5, 4, 5, negative 7, and 3. Don't forget to transpose the matrix. So it becomes 1, 9, negative 2, negative 2, 5, negative 7, and 3. Okay, so now we have found the adjoint for matrix B. Okay, so now let's proceed to find the determinant. Okay, proceed with the determinant of matrix B. Okay, determinant of matrix B, or could also be written as like this. So will be equal to, okay, for this one, since you have already calculated the cofactor for matrix B, okay, for example, you have this row 1, 9, and negative 2. You could just take that value of cofactor and multiply with the first row from the matrix B. Okay, take here. So this is matrix B. So then the determinant is just, we take 1, multiply with the cofactor 1, okay, then plus 2, multiply with 9, the cofactor, plus 3, multiply with negative 2 from the cofactor. Okay, now we have found the value of determinant of B, which is 1 plus 18 minus 6 equal to 13. So this is the determinant. Okay, now we have the adjoint and we have the cofactor, and substitute it into the formula of inverse. So B inverse equal to 1 over determinant of B multiplied with adjoint of B, okay, equal to 1 over 13 multiplied with the adjoint, which is 1, negative 2, 5, 9, negative 5, negative 7, negative 2, 4, and 3. Okay, you multiply, it becomes a scalar multiplication. So then we have 1 over 13, negative 2 over 13, 5 over 13, 9 over 13, negative 5 over 13, 7 over 13, negative 2 over 13, 4 over 13, and 3 over 13. So this is the inverse for matrix B. Okay, quite a big, long process, which implies all of the knowledge you have learned before in this topic, which includes the scalar multiplication, minor, cofactor, determinant, adjoint, which has transpose in it. Okay, then with all of the background knowledge, you can find the inverse for matrix B.